yeah. I'm just going to implement what I already said on Discord. Nothing special. That won't work. Shit. I think anything goes, right? As long as I can divide by it. Let's do something ridiculous. Fuck. U minus diff. Yeah, sorting. Total number of solutions. 1, 2, 3, 4, 5. That's a lot of ifs. Yeah. Actually, we don't. Damn it. No, sorry, because it could be swapped now. So I don't know which is which. Depends on which D1 is less. It's D1 or D2, I mean. I'm just going to do it the stupid way. The stupid slow way. Anything can happen, but in almost all cases it's going to be one of two possibilities depending on which delta is smaller. So we would like to fast track it, comparing them. Yeah, fuck this. Mess. A double 2C, first element. One more. Second element. No, let's do it on the stack first. This on stack should not be initialized. Although it's probably faster to initialize it. So I'm going to store I'm going to store the results of the subtraction, which leads to 0 or 2 solutions, into the first array here. So 2 solutions or 0 solutions. So the actual number is then stored in count. So count contains 0 or 2, depending on the index. So the index stands for 0 is subtracting the diff and 1 is adding the diff. Same for all indexes here. And then the C coefficient. The C coefficient of the polynomial that I want to determine the zeros of is, in the case of subtraction, of course, the difference for each coefficient. So for C, that is the C coefficient minus the C coefficients of the diff, and then adding it for the addition, so the second argument of this array. And this thing just contains the same values within the absolute value of that. Keep track of a sign. I have to divide by the absolute value, so I want it to be larger than 0. If it is not larger than 0, then it's equal to 0 and I can't divide by it. Therefore, yeah, well, if the C coordinate is absolute value is 0, the C coordinate is 0, so you don't have a problem, then it's a straight line, which then gives me at most 1 0. 0 0 is a 1 0. We don't add that, so I want 2 zeros or nothing. So then we don't do anything, and otherwise we calculate the B coordinate of the polynomial, which is this is the B coordinate of the current one plus the sign, or whether or not to subtract the diff, and then the B coordinate of the diff. And then the discriminant is b squared minus 4ac, where this is the a value, or subtracted the y coordinate of the vertex from the current one. And then we see that we made a mistake here, because this must be plus the sign times the diff, so either subtract or add it. And then if the discriminant is larger than 0, then we have two solutions. And the average is minus a half times b divided by c coordinate, which was calculated up here already. And the delta is then a positive value, therefore I use the absolute value and plus a half. And because delta is positive, then this one is the smaller solution and it is the larger solution. And then we store for I is 0, there was a subtraction, so it's the diff being subtracted. We store that in here, and otherwise, yeah, store it in index 1. And then at the end, I have to write these to the output variable. So at the very least, now I can say that I seriously call this array count, because this array equals count. Let's call this count out then. So I can say that count out is count 0 plus count 1. Yeah, I guess how do we do that? No. Let's say we have I. It's another I. I'm gonna call this one I0. Start at 0. I have an I1 is starts also at 0. And then have an output I. And then I get totals out. Totals out I becomes the next value. I already have a count out. Maybe that is faster. Yeah. So So this becomes obviously either one or the other, which is then toggle 0, I0, or toggle 1, I1. If I1 equals count 1, if that is the case, then we don't have toggle 1 left anymore. So then it should be this anyway. Not only that, now we used up that one, so let's increment it. Else there should be things left in the other one, because there's nothing left in here. But if there are stuff left in both of them, yeah, something like this. No, too lazy to check it. I'm just going to add a search. Lazy asserts at that. surely I can print no, dus, color. Well, I never can figure out how many braces are needed for those arrays. Excess elements. No, it's excess elements. Dude, the F. This argument equal interest is type const. Okay, make syntax vr equal intervals probably should be constant. Now this worked because I did that while off screen. So we have the old parabola. The old parabola is the red one here. The new parabola is this blue one, which both are shifted such that the blue parabola has its vertex at 0, y is 0. And then I mirrored the blue one in the y0 axis because yeah, I just wanted to be have a minimum. Then the yellow thing here is the difference between the two times 10. So you can see the difference here is this times 10 is that distance. Well, the difference here is clearly 0 because red and blue cross. Therefore 10 times 0 is 0 as well. And it's the absolute value. So two parabolas subtracted from each other is a parabola, but if you take the absolute value you get something like tok, and then it goes back up. And now we can compare this 10 times difference with the mirrored new parabola, and then of course if that difference or 10 times the difference is less than this blue one, then they are close enough. So yeah, the 0 is always less than that because it has a minimum where the vertex is at 0, so everything is positive except exactly in the vertex. So at the moment that the minimum is 0, it's always less than, and that is because they are exactly equal at that point. And then from there we go up, so we always cross then that blue parabola here, at which point the difference is equal to 10% of the blue parabola, the height of the blue parabola, that is, so relative to the vertex. And that's where I draw a lot of vertical lines, namely the purple ones here and that's all 4, are found with brute force. So just I made really tiny little steps, and for every step I calculated my ass off, and then just figured out where stuff is equal. And then the dotted lines are what my algorithm is calculating. As you can see, they exactly coincide. And then I wrote a new algorithm, which we just wrote, and that gives me these toggles. And that output says, is it close at infinity? No, because at infinity the difference is way larger than that. So here is the bad area. And then we toggle at this point because now they are close. And we toggle again, so now it's the difference is too large again. And then the toggle it again, the difference becomes less, and then we toggle again, and now the difference is again too large. And since there are always an even number of toggles, at infinity holds for both minus infinity and plus infinity. Yeah, because it's false here, and then true, and then false, and then true, and then again false, because there's 4 lines. But we have to check that these values correspond with what I have already drawn. And that is not that difficult, because you can just look at the values. That was recalculated again, but you can see it here already. So this dashed line here is at minus 5.01463, and that was again calculated here. And that value we see also back. And this minus 4.51711, that would be this one, which is can be found back here, and the other one can be found back there. So it worked, and they are in the correct order. So the output is okay. And I'm going to press space. Now we get a different one, and now we have to check that again. Okay, so it is false because, well, this one is larger than blue. And then we see increasing in size, so that worked. And we see this value, and this value, and this value, and this value. Or rather, you can just look at the with zeros, so those 4 zeros should appear here as well. It's again false, it's again sorted in the right order, and the values are again equal. Yep. Now, this is going to be every time the case. If we have something like green and red on the outside. Let's go to, well, here at least they are upside down. Let's check that one. Still green and red on the outside though. It increases in value, grades, and the values are the same. And the false is still correct. Now this one may be special, I don't know. They are very close. It's just a special thing that is close. Yeah, there's still the outer values, you know, the smallest and the largest are still the zeros here, so not that special. I'm going to try and find one where that is not the case. Maybe we should just look here. Jump up. Well, there's an interesting one. There's only 2. Well, they increase in value. There's only 2, which is these 2. And that is because this one did not have any zeros. So that works, I suppose. Now see here the new algorithm works and the old one doesn't, because the old one says no zeros found, while the new one says we have 2 toggles. In this case we start at true, so this means that everything on the left of this line and on the right of this line is close enough, and everything in between here is deviating too much. Well, that's correct. And again. No, it just works. It just works. I still want to find one where they're not on the outside, which is almost always the case, I must admit. Or say. That is maybe going to take forever before I find one. What is this? -7 and 244. Yeah, I can't see that one. See, this is why I wanted to speed up my sorting routine, because it's like always like this. Might as well put them in this order to begin with. Yeah, finally. So here it's done not on the outside. Red is still on the right, but green is now no longer the one the furthest to the left. But hey, it's still sorted, so that works. No, okay. I think you can safely say that it works. Entering main. Okay, wait a minute. That's a serious bug. I have to fix this one. What the kind of nonsense is that? Don't tell me I have that. Done more often. Oh. Comes from gradient descent apparently. Entering, leaving, entering, leaving, entering, leaving, entering, leaving, entering, leaving, entering, leaving, entering. I just fixed that. Entering, okay, now it's fixed. Yeah, let's just commit it, or shall I do? Polynomial. Yeah. Yeah, you can't commit this, right? It's just too much nonsense. What is this? Skill update. let's remove all this. As in this new code is going to be going to replace everything. Update. Yeah, so now what? You want to find the next toggle in the direction of the vertex. Mm-mm. Yeah, I'm gonna do one past the end, right? So the beginning, this is versus beginning. Maybe I should call it begin and end. So the end count is 1 past the end, and then therefore you must use -1 here. And we begin at count -1 here. So now we run from 0 up till and not including count, or from count -1 up till and not including -1. And then I want to search for it's problematic that I need to keep track of infinity as well. Okay, because only one of the infinities really matters. Let's say so I have a minus infinity here, toggle, some interval, toggle, and then let's say 4 toggles, and then plus infinity. But I'm running over only 4 values, right? Starting at 0, or for if you run left to right. So then my 0 must correspond with this 1, 2, 3, and we will never reach plus infinity. I said 3. Or 0, 1, 2, 3. But in both cases, this is the index of the toggle. So I could move this up. See, it's on that side. And here it's on that side. Now at any point you can have 3 values, namely the vertex. I'm gonna put it somewhere. That is Vx. And the sample value, I guess, the new sample value. I think the starting point is the edge sample W. Not being used anymore. Sure, I guess that's the old one. Yep, totally the old. Is another value relevant though. Okay. Oh, that is this one. It's simple double. Yep. I think I deleted the code relevant to this already. Yeah. Yeah, because Yeah, I would say that if I would say that the order is always this or reversed, but I'm not sure. Yeah, Vx is the new parabola, and edge sample should be the W value of a sample that we took, which caused that parabola to be calculated. Am I saying that correctly? Yeah, it could be on the other side if we had an overshoot. Yep. Oh man. Suppose you can ignore this value and then just at the end take the largest one, which I've been doing already. No, I'm not. Well, I should. So if I ignore this value for at first, then what I really want is just find a value that is as far as away from Vx. It's not that easy. I need to find the interval, I think, in the direction of the vertex, that is valid starting from the edge sample. But what if that is plus infinity already? Oh, then it is plus infinity. Why not? Yeah, it's not like this is valid, right? If we have 4 of them, then this is going to be invalid, and this is valid. So if you are at infinity, I just want to find this one. But. This is way too difficult. My god, why is this so difficult? I think I'm going to split. I'm going to duplicate code because I can't totally understand this. I'm not doing it at the same time from left to right and right to left. So if each side equals left. Let's begin with left. To left mean to run from left to right. Therefore, this is the case here. Now we begin at 0. And then if this edge sample is less than the toggle, then we are in the minus infinity range. Therefore this close holds, because that is the value that corresponds to plus or minus infinity. And the interval I call 0, which is just on that part. So we break out of it. If it is not less than this toggle, then it's on that side. So increment I, and then we are talking about this interval now. Interval 1, and I toggle the close value. And then we continue. And if now it is less than, then well, it's in this interval, so we break, and so on. So this should find the interval in which the edge sample is in. And guess I need to do the same thing for the vertex though. Or do I? Not really. Not really. Okay. Find the nearest interval. So we end up in an interval that is not close. Then, for example, in minus infinity is not close, but that's where we are. Then I increment it to 1, corresponding to this interval, which is close then. And then of that interval, I want to have the largest value that is as far away from the vertex. I'm assuming here that the vertex is just to the left all the time, to the right all the time, I mean. So I'm going to use this value then, which is the value of the toggle of I minus 1, or minus infinity if it is 0. Get the minimal value that is close. I don't know how else to say this. Double min, yeah, I don't know. It's going to be the new edge. Do I already have that defined? New edge W. So totally not defined. Hi, Daily Hack. Oh, it's going slow, incredibly slow. Maybe I should initialize this. I'm just going to initialize it with VX. So if I equals 0, then we are in the minus infinity range of interval. Basic syntax in 3 months. Yeah, it took me that long as well. And then we're talking pre-C++ 11. C++ is pretty big. C costed me 3 weeks, actually. Although maybe I did learn more than just the syntax then. I think in those first 3 weeks I finished writing a little program that opened a socket with a TCP connection. Just some super simple test case from the man pages. Okay, so if I is 0, then we sit in this interval, and I don't want to use minus infinity, I just want to use the old value then, which yeah, it sits in that interval. And otherwise, if it sits, wait a minute. Well, but did or did I not do this increment? It's always this value, unless you do this increment. Yeah. Use the old value. Unless it is too far away from the new parabola. I think that works. So if we are here, well, this is invalid, so we go there, then we use this value. And if we are here and this is valid, then we just use this. And if it is invalid, then we go to the next one and we use this one, and so on. So now I'm in the leftmost border, or what was this? Leftmost edge of the a valid interval. That is as far to the left as possible, but not further than the original example. It's a mouthful, but it sounds correct. Sort of. And then, yeah, incrementing, I don't care about that. Who cares about I? At that point, which means that I might as well then make a for loop for this, because I don't need I. I need I outside of the loop, I mean. I'm gonna make this a part of it. Okay, now there is another problem. We might have overtaken Vx, which is definitely not allowed. And I might even have overtaken edge sample. Let's call it a limit or something. Oh shit, let me think. Probola is the vertex of the new probola limit. Yeah, well, hardly, but yeah. Yeah, well, no, but I don't know what to say about it. If I ignore it, then that's good enough, isn't it? You see, we do what we do, or I set it equal to edge sample, which then gives me the scale that I would have had when we didn't even have a previous symbol. The scale is a difference between the vertex x coordinate and whatever. So here. So I limit my new value to this old value. Well, no, not the old value, but the new value. This one. This one. Then, in effect, I would do this minus Vx. And this is all going to the right. So it's getting larger and larger. Okay, I'm just limiting it. Don't go beyond. Yeah, I think this is about it. And then put everything in one line, of course, because this is way too readable. I have 3 comments. If I put it all in one line, then at least I can delete comments. Right, and I can do code duplication because now we go right to left, which means I start at count -1. We continue until -1. Minus, close to toggles, and now this is larger then. I think anyway. So check if this is correct. We start at count -1, that is 3 of course, which now belongs to plus infinity. And then if edge sample is larger than the toggles of 3, then we are at the right place to break. So it looks good actually. And even the comment is exactly the same. And then we have the new edge is now the maximum of nope, suddenly does not make any sense anymore. This is wrong. Let's go back. Oh man, I do need I. Arg. No, wait a minute. I was mistaken. Either, yeah, I don't care about how many invalid intervals still come. I just want to use the valid interval, and from where we are to its vertex that is the nearest that is valid. Ugh. Therefore, either we are immediately valid or we have to swap one step. That's that. So the code was correct. Sorry. Let's redo everything again. this doesn't look good. Just does not look good at all. It is not good. It's definitely not good. Wait a minute. This is, why is this so hard? Ridiculous. How do you know it's in? Okay. No. Yeah. 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 Yeah, yeah, I think so. Right. Well, that means that it is always set, so I don't need a default here. Ridiculous default. And then, what was about this? I think it works. This is I is no longer known, so I did need it. No, I'm gonna make it a while, otherwise it just looks silly. I don't like that. Yeah, I need to run this one. 80 cents. This looks wrong because the previous, I'm not showing the previous parabola anymore. Maybe I should do that. The point is that this blue line is a sinus, but it's more or less equal here to the previous parabola. So let's say this is a previous parabola, and I just artificially moved the parabola just to test it. So now the Actually, this is the new one. No, what? Yes, of course. With respect to the other test, I think that the red one is the new one, and then this is the old one. Artificially moved somehow. It's a bit too artificial, if you ask me, because the vertex is still put here. To the calculated vertex. If this is the new one, then it should be there. This whole artificial moving doesn't really work. Maybe I should just stop with doing that. I need to I need a better test somehow. There's my artificial move. Is that to fix me? No, it's not to fix me. Oh, here it is. No. Let's just not do this. Oh, I don't get anything with this. Okay, so what do we have here? This is the scale. This is the parabola that is being used for it, and this is initialization. That meaning this is the first parabola, the red one, and it sets the scale to the distance from the vertex, which is not coincidentally going through 2, because 2 is set at the vertex. So this is the vertex, and then 0 is being used here. And why is 0 being used? Because 0 is being passed as one of the samples. So we have 2 samples, 0 and 1. Those samples, that's not just the height but also the derivative at that point, the slope, gives us this parabola as a fit, which kind of missed the mark here, but okay, that's because these points are pretty close together and this is a sine. Nevertheless, it's the first parabola that we have, and 0 is part of it. So yeah, Oh, well, let's scale to this distance. There is nothing wrong about that. And I'm gonna hit space, and then it's going to plot a parabola through 1 and 2. And as you can see, 0, which is now in use, is like literally on the parabola that we had, the old parabola, together. This in this neighborhood, 0 and 1 are a perfect fit to the sine wave. So plotting the point through 2 and 1, well, not through it, but through 2, having a derivative equal as well in 2, and you can't make it go through 1 and have a derivative the same. So I did choose to have the derivative the same. Anyway, this is our new parabola. And then normally I would say the new width is from 1 to the new vertex, but the old point, it doesn't deviate that much from the new parabola. This distance is less than 1/10 of the height of the new parabola relative to the height relative to the vertex. It's really tiny a little bit. So I think, well, I say, well, let's still use 0 as the edge sample, edge being the furthest away from the vertex. And therefore the width is now still from 0 to the new vertex, 3. So the scale was reduced, but only because the vertex moved. And now we press space again, and then it's going to plot a parabola through 2 and 3. And that will probably give almost the same parabola, because we're already there almost. Which again passes very close to 0, so we should still keep 0. Yep, and it does. So the vertex shifted again a little bit, 1 character width, tiny little bit to the right. Still keeping this edge sample, and the width is now tiny little bit larger again, because the vertex moved. And now it becomes interesting, because now if I hit space, it's going to plot a parabola through 3 and 4, which is super close together here. And now we might deviate really big from 0. And then the question is which samples it is going to use. Oh, still 0. So apparently it was not that much different. This is still close enough. But now the new point, 5, is 100th away, less than 100th. So the next parabola is really going to be noise, if you get what I mean. Okay, that's interesting. It didn't move. It did move. It removed the 0 point, though, but my history is not long enough. So the parabola is still going almost on top of this point. And another space. And again, it's unbelievable. Well, I guess this is the parabola that just fits the best to a sine here, no matter how close the points are. And it is also close enough to the starting point. I would move it further away, but if you move too far away, it's gonna go uphill, I think. Or not. Maybe, no, maybe not. Let's start here, 23. Let's start at 23 and a half, see what happens. Oh, that's ridiculous. Oh, okay, yeah. Now these are now so close to the turning point of the sine wave that it is almost a straight line. So the vertex of this parabola is like way to that side. Not helping. Maybe I can artificially force this one. Let's say I want to continue at 30 or something, not larger. I'm not sure how to do that though. What I really should do is just use this function that I prepared here. Either I have to move my gradient descent stuff into that or this function into that. Because no, I can't use it. I'm not even using that function anymore when I think about it here. So I probably should move this function over to the gradient descent and then try this one. Let's do that. Might as well delete it. Function L, yeah, as if that is being used. Capital L. L is string, so big that it wasn't even readable. It isn't even doing gradient descent. The other one is going to do this. No. No matching constructor or initialization of history. What is he talking about? But it takes a function. Okay then, function. Failed. Uncloud identifier L. Parabolic scale. Well, I changed that. It's just a window title, maybe. Yeah. Oh, parabolic scale test. Choose that here as well. Oops. Oh, okay, yeah, my W values are now bullshit. Question how we do it or whatever. Not having an automatic. Look in the wrong file. Descent. There it is. I don't know. I really don't know. Let's just take it a really big and wide range. So nobody knows what to use here. That's automatic. The king was around 0. Minus 10 till plus 10 isn't that bad, I suppose. It's like that. Okay, no. I'm not sure. Looks like here's a king. This is impossible. It is around here, yeah. Around the W's 0. So this part is a parabola, and then it sneakily changes into another parabola. So we can fool it. Okay, here there's a neat descent, and it thinks that it is on this parabola. So yeah, does make a small step, probably pretty small. It makes a huge step. What the hell is this? All the way from here to there. That does not make any sense. Okay, I want my initial step to be like this small, right? It's like even one would do, or half maybe. Why is it making that huge step? Maybe initial learning rate is being used, I think so. Yeah, probably. Well, let's set this to dot, a tenth of that. It's probably still not small enough. Yeah, I want less. This is ridiculous. Doesn't even look like a parabola, this one. Parabola. Have you already been influenced here? Okay. Let's halve this value and maybe even move it up a little bit. Let's start at 5. Start at 5. Starting learning rate 10th. That's a straight line. Now we have a problem. Okay, so it does find obviously this parabola exactly, and then here you see the bumpy thing, and then we go to a totally different parabola. It's not even close to there. Okay, yeah, well, and then number 2 is the vertex of this first parabola. So now it did try to fit something through 2 and 1, so the derivative here is the same. New vertex is in 3, and it did keep the edge sample number 0, because apparently this is still less than a tenth of the height. No more. So now the distance became too large, and then it jumped there. I have no idea why it jumped there. Come on. If this is good, then why is this not good? And this 1/10 of this height? Easy here. Easy decimal point. Why that point? No, I don't like this at all. At the very least, I need to keep drawing the old parabola as well, so we can really compare what's going on. But yeah, I think this parabola more or less continues still here, so it's, I think it was something like this. certainly equal to the purple thing here, all the way. So there's absolutely no reason to go to that pointer. No reason whatsoever. Excusez-moi. Need more debug coverage. Unfortunately, I'm going to bed. It's just a hard cut off here. So again, an hour later than I want. I'll continue this in the Woer tomorrow and the day after and the day after.